Evening, all of you. Hope you all are doing well. Let's start with today's session. Quick recap of yesterday's session. Yesterday, I took some operators, equality, inequality for primitive. Then we discussed equality, inequality for objects. Then we have discussed Boolean logical. And the speciality I've told you in that the three operators which are there, and, or, and XOR. They work on integers also as bitwise, and they work on Boolean also as Boolean logical. So yesterday we have discussed only on Boolean. On integers, we haven't discussed yet. We'll be learning it today. And then they are compound form also we have seen. Compound Boolean logical assignment. And equal, or equal, XOR equal. Okay. And last, conditional operators we saw. The conditional logical operator, to and, to or. Their specialities, they operate only on booleans and they are short circuit evaluated. Get it? Whereas single and operates on, because this is a common interview question, difference between single and two and. Single and can operate on integers as well as boolean. Two and operates on only on boolean, and two and fully evaluated, whereas double and short circuit evaluate. Only A is evaluated, B is decided whether to evaluate or no on A's result. Okay, so all that discussion in the last session. Today, based on the past knowledge, whatever we have studied till now, all the operators, based on that, some MCQs you'll solve. Now, in this, which of the following expression evaluates to true? Okay, so in the first case, this is single OR, and I've told you this is Boolean logical. And in OR, when one is true, the result is true. Any one, if both are true, one single value is true, the result is true. So this result has to be true. Okay. Now, is null not equal to null? Is null not equal to null? No, they are equal, but you are checking not equal. Therefore, this will be false. Is 4 less than equal to 4? Yes, therefore it is true. Not of true is false. Okay, and true and false. Now in ANDing, when one is false, the result is false. Okay, so only these two are true. Which one? False or true? And 4 less than equal to 4. Right? Hope it is.
Yes, sir.
Then the next question, which statements are true? Select the two correct answer. Checking the first one, the remainder operator mod, remainder and reminder. They are the two different English words. This is remainder. Whatever remains, we call it as, and when we remind something or we tell that, please tell me this thing. So you put a reminder. So the remainder operator mod can only be used with integral. So this is not true in Java. This is true for C, C++. For Java, this is not true. In Java, modulus can be applied on floating values as well. You can apply it on floating values as well. It is valid 5.5 if I write modulo 2, it works fine. Okay, it will give result 1.5. 2 to the 4, remainder 1.5. Therefore, it is false statement. This is not a true statement. Second, the identifiers in Java are case insensitive. It's not like that. They are sensitive. If I create a variable age, okay, and I'm creating another variable age, a small, here a small, here a is capital. Both are different. Java doesn't consider both as same. Both are different. Therefore, this is also not true. The arithmetic operator star, div, and modulo have the same level of precedence. Yes, they all three have same level of precedence. And then a short value ranges from minus 128 to plus 127. No, this is the range for byte. The range for short is 32,000 positive, 32,000 negative. मैंने minus 32768 to 32767. Getting? Therefore, this is wrong. And plus 15 is a legal expression. You can write plus explicitly. This is an assertion operator, which is legal. If you write 15, it is assumed positive. And if you write plus 15, it is assertively positive. I mean, this is confirmed that it is positive. And when you don't write plus, it is assumed that it is positive. Okay. So only these two statements are correct. Okay. So hope this part is also clear to you guys. Then one more question we'll see. Which statements are true about the lines of output printed by the following program? Now, in this program, there is one method OP. OP is one method which is taking two Boolean values as arguments. Hence, you're passing two Boolean values as parameters. Whenever you'll call, so at that time, you're going to pass two Boolean values. And whatever Boolean value you're passing, they will get copied in these parameters. Like you're passing, wait, guys. अरे हेलो ओ भाई साहब हेलो हेलो वो काम बंद करो ना मेरा क्लास चल चल रहा है any तरह to switch off उसके वाले. Okay, sorry for interruption. Let's continue, guys. So whatever values you are going to pass, that false, false, that will get copied in this A, this false in B, and then operation will be done. First thing, remember, OP is the name of the method. It is taking two parameters of type Boolean. It is not going to return anything, therefore void, and it is a static method, meaning to invoke this method, invoke means to call, you don't have to create object of this class, Boolean OP. No need to create object because it's a static method. If it's an instance method, then to invoke it, you need to create a object. That is the basic rule you have to remember. So as it is a static, no need of creating object of this class to invoke it. And if you're going to invoke it in the same class, even there is no need to attach class name. Normally, if it is a static method, then you invoke it in context of class name, whatever the class name is, dot and method. Okay, like this. And if it is an instance method, then you have to first create the object of that class and then object dot foo. Okay, so why I'm not writing class name also boolean op dot, boolean op dot, because I'm calling it in the same class. Now four times I'm calling with different combinations. So what will be the output for all four? That first we will list out and then we will see the options, whatever the options are. Okay. So in the first combination, what is passed? False and false. So what will come in A? False, B false. Okay. So tell me, is false not equal to false? Are they not equal? No, they are equal, but you are checking not equal. Therefore, C will be false. Okay. Now about XOR operation. A is false and B is false. In case of XOR, when both are different, the answer is true. And when both are same, the answer is false. So as both are same means both are same Boolean value, false, false. So XOR will be false. Okay. Now, is false exactly equal to false? C has come false, D also has come false. Are they both exactly same? False is equal to false. Therefore, E will be true. It will print true. So in the first output, you're going to get true. Okay. Now, considering. So therefore, first output is what? True, guys. I hope you will remember that. Okay. Now coming to the second combination. One is true and one is false. A is true and B is false. Are they not equal? Yes. Therefore, C will be true. Then, are they different? A is true and B is false. They are different. Therefore, answer is true. So, C is true, D is true. So, is true equal to true? Yes. Therefore, E will be true. Okay. Now, in the third case, false and true, the same thing is going to happen. Yes or no? Once true and false and true. Here you will get true only. And in the last case, when both are true, check, is true not equal to true? No, it is equal, but you are checking not. Therefore, C will be false. XOR operation, true XOR true. As they both are same Boolean, the answer is false. And is false equal to false? Yes, the answer is true. So E is true, you'll get true. So in all four cases, you will get answer true. Isn't it? Hope it is clear. Now, From this four or five options, whatever, whichever is the right that you tell me. Let's see who will tell. Anyone?
All lines
Anyone?
printed are the same.
Okay, the first one you want to say all lines printed are the same. Why? Because all are true only. Okay. Then what do you say? At least one line contains false. No, at least one line contains true. Do you agree? The first
Yes.
line contains false. No. The last line contains true. So from this, do you agree that these three are true? I mean, these three lines are correct. That all the lines printed are true. At least one line contains true, and the last line contains true. Do you agree? Okay.
Yes, sir.
Then, next question. What happens during execution of the following program? Let's see if I hope if you remember binary string concatenation. I've told you about binary string concatenation in the not last lecture, before that we have seen. Last to last lecture. Okay. Now here I is 0, which is created on stack part. Okay. Then A, which is the reference variable, is created on the stack, but the array is created on the heap part. On the heap, array of two integers is created. A separate, elaborated, exhaustive topic on array is going to come. Here we just start discussing related to operator. So at 0th position there is 3, 1st position there is 6, and the reference of that array will be in this array variable, because in Java arrays are also non-primitive. Arrays are non-primitive, they are not primitive. And if it is non-primitive, it is reference. Reference means object. That is a simple rule. Java says if there are 8 primitives, that is boolean, byte, short, int, long, float, and double, and char. From this, if you are creating a variable, it is primitive. It is directly holding the value. And other than this, okay, like string variable, employee variable, array variable, they all are non-primitive. They are not scalar. They are group of scalar value. They are non-primitive. So they will be a reference variable. Actual memory is on the heap. The reference is here. Okay. Now coming to this part. Now coming to a of I equal to 9. Okay. So what happens is when you wrote a of I, the value of I is already evaluated. I told you yesterday, evaluation. So I is already evaluated to 0. Okay. Now you're storing 9 in I. So I becomes 9. And then A of I. But this I value is already evaluated. I told you, no, bracketing rule. So what is the value of I which is already evaluated? It's 0. 9 is stored in I. Okay. And then that I is getting stored in A of 0. It is not A of 9. If it is A of 9, means you may think like that 9 is stored in I. So I becomes 9, and then it is trying to store that 9 in A of 9. And A of 9 is not there, therefore it will throw an exception, array index out of bound. Like in Java, when you try to access beyond the limit of that array, the limit of the array is 0 and 1. Beyond that, if you try to access, it will generate array index out of bounds exception. But this is not going to happen, guys, because this I, A of I, is not taken as this new value. It is already evaluated to 0. So A of 0 will become how much? This I, which is 9. So A of 0 will become 9. Okay. And then you're trying to concatenate it. See, in between there is string. So I plus string plus A of 0 plus string. So I hope you know it. When one of the operand is a string, another is automatically converted to string. Binary string concatenation, we have studied. Okay. So when one is a string, the other is automatic converted to string and concatenation. So I is 9, 9 concatenated with space. Then A of 0 is 9, again space, and then A of 1 is 6. Getting? All these things are getting concatenated. And you get what? A complete string, 9 space 6. Okay? So hope that part is clear. You can check the options. It throws an exception of type array index out of bounds. One thing, 996, 906, 936, or 939. So which one from this do you agree? Others are there or no?
Option B.
Think. Option B. Others, other than Harshraj. Others also have to answer. I hope others are there or gone. Others are there, Harshraj.
Yes.
Yes, sir.
So others. Yesterday the same thing happened. I asked uh, Siddhant. He said no one is there. I am alone. Very bad. Right? So do others also agree with that? The answer is 996. Please
Yes.
remember when this assignment is done, 9 is stored in I becomes 9, but that I is not used here. It is already evaluated. Getting? And what is the already evaluated I? 0. Therefore, A of 0 becomes 9. So what was A of 0? 3, that has become 9. But the same thing, if you try to do it in C, it will generate a runtime error, means core dump concept, means something wrong has happened. You have tried to access a wrong memory. That time the system crash takes place and that core dump printed. If you try it in C, here it's not like that. Okay? Okay. Again, if you're putting it in the comment, generally I don't see comments. Moving ahead, some more questions. Which statements are true about the output of the following program? Okay. Here, just what we have to see is in this whole operation, if you remember, in yesterday's session only we have discussed, if it is a single AND, A single AND B, in that case, irrespective what A is, whether it is true or false, it has to evaluate B. Getting? Because it is single, it is fully evaluated. But if you use this logical AND, getting? Conditional logical operator, it is short circuit evaluated, guys. Means if A is false, complete false, it will not check B. And same way in ORing, if A is true, complete true, it will not check B. That is only the difference. You have to remember that. So that is only checked here. Somewhere single AND is there, somewhere two AND single or two OR. So whatever is getting stored in F doesn't matter. What is getting copied in F is irrelevant. Main thing is I changed and is J changed or not? That is important. And finally, you are printing I and J value by concatenating it with a space. Concatenation will take place. I is the integer and this is a string. So I will convert to string and then that string and this string concat new string. That new string with J is again converted to string. All that things you should know now. I don't have to again tell you. Okay, coming to the first one. See, what is T? True. T is true. And the operator is AND. Single AND. So irrespective what the first is, it is true or false, doesn't matter. It has to evaluate the second part. Do you agree or no? So whatever, that T is true and it has to evaluate this part. And when it is evaluating, is it incrementing I by 1? This is compound arithmetic. I hope I have taught you this also. When I took arithmetic operator, after that immediately I didn't prepare a slide of it, but I have shown you compound arithmetic. And I told you the difference. As it is compound arithmetic, it is having lower precedence because it has gone with equal, and equal is having lower precedence. And only the speciality of compound arithmetic is implicit casting. In compound arithmetic, this is the only situation where implicit casting takes place. Otherwise, Java doesn't. Implicit casting means implicit narrowing, I want to say. Sorry for that. Implicit narrowing. Normally in Java, narrowing doesn't happen automatic. Only widening is automatic. Narrowing is not automatic. But here happens. Okay, so whatever it is, tell me, I is 0, 0 plus 1 is 1. So is it going to make I as 1 now? Okay. And then is 0 less than 1? Yes, true, this is true and true, the answer is true. That doesn't matter. Main thing what they want to check is whether both the parts are evaluated or only the first part is evaluated. Getting? So according to single and both are evaluated and therefore I becomes 1. Coming to next case, it is 2 and 2 ands are short circuit evaluated. It will check first T, but T is true. So as T is true, it has to check whether the second is true or not. If suppose the first part is coming false, directly it will announce false. It will not come to second part. But as they are two and the first part is true, it has to come to the second part. Now in the second part, it will increment first I by 2. It will make it 3. Okay. And then compare it. Whatever, 0 less than 3 or no. Okay. So whatever, this is true, this comes true, the final is true. Coming to ORing, but it is Boolean logical, single OR, which we discussed yesterday. Here, fully evaluation is there. Getting? So T is true. This part also it has to evaluate because fully evaluation, J is incremented by 1. Okay. Then whatever the result is true or true. Actually, in ORing, if one is true, the entire is true, but still it has to evaluate both. And coming to the last one. In last one, T is true and it is a OR operator. Two OR, meaning two pipe sign. So this is a conditional logical short circuit evaluated. And as T is true, the entire result is true. It will not come to the second part. You understanding? It is not going to increment J by 1. Is it going to increment J by 1? No. J will remain 1 only. J by 1 is J by 2. Okay, so this part won't happen only. Why? Because it is a short circuit operator. As it is a short circuit operator, it will only evaluate the first operand, and on the result of the first operand, it will decide whether to evaluate the second part or not. So, as the first part is true, it doesn't come to this part. So, what is the final value of I and J? I has become 3, but J remains 1. Getting? So, select the two correct answer. Can anyone tell me quickly?
C and D.
C and D. The first digit printed is 3 and the second digit printed is 1. But are you convinced that why I got incremented two times by 1? Once it got incremented by 1 and second time by 2. But why J didn't?
Yes, sir.
Sure. Because in the fourth case, you are using short circuit OR. It doesn't do fully evaluation. It only decides on
Yes.
the first operand. So first operand is true and it is a OR operator. So in OR, if first is true, the entire is true. It will not do this. But when you use single OR, irrespective what the first is, it has to evaluate both. Getting? And why in ANDing it has come for both, you got it. Because when we wrote two and, the first is true, therefore it has to check whether the second is true or not. If suppose in this case, if the first is coming false, direct false, it will not evaluate the second part. Okay. So hope that part is clear to you guys. Moving ahead.
Yes.
Now quickly moving to next operators. Right on a lot many things you have to learn. Not only operators, guys. So many things are there. Java is so exhaustive language. Okay. So only operators we have to learn control flow after that. Then we have to start with classes, objects, constructors, inheritance, interfaces. All these things are there in core Java. So many things. Collection framework we have to learn. Streams we have to learn, and which are very, very favorite topics in freshers interview. Okay. Moving ahead. Next, we are going to discuss integer bitwise. Yesterday, the same three operators we have discussed. And I showed you also their Venn diagram. I told you this is tilde operator, and operator, or operator, XOR, and not. Getting? And I did this overlapping part. This group, okay, and I took this group. Okay, so what is overlapping in both the group and or XOR? Here, not is separate, tilde is separate. But in that group also these three are there, in this group also these three are there. So what is the speciality? Remember, tilde operator only on integer. Tilde operator you can only apply on integer. Floats and double not allowed. Boolean you don't think only. And character allowed because character is also whole number. So tilde only on integer applicable, not only on Boolean applicable. Only Boolean. You cannot apply it on any other data type. But these three operators which are overlapping, they can be applied on Boolean, which we have discussed yesterday, called as Boolean logical. Okay, and we saw just now an example where it was working as Boolean logical. But they can be applied on integers as well, guys. Integers, when I'm saying integers, means I'm not talking numeric. When I say numeric, means float double are also inclusive. I'm talking integers, means only whole number, byte, short, int, long, and char. No float, no double. Boolean, don't think only. Okay? So, what is the speciality of these three operators which I've put common over here? Can anyone tell me their speciality in one line? They can be operated on
both integers
Small
and
float integer double.
both Boolean also, integers also. If they are operated on Boolean, it will be called as Boolean logical, discussed yesterday. And now today we are going to discuss as integers. So they will be acting as integer bitwise. Okay. This tilde only on integer and not only on Boolean. Okay. And they have their precedence, not and they are unary, so they have higher precedence. Then in this three also they don't have same precedence, and is having higher, then XOR and then OR. Remember, and is having higher precedence, then XOR and then OR. Okay. So now we are going to discuss under which data type? Integer data type. Okay. So if you're applying these operators on integer data type, what it does is it takes that operand's memory representation, whatever the memory representation is, like you are writing tilde of 5, or you are writing 9 and 23. Okay. So what it is going to take? Their memory representation. And what is the memory representation of an integer? Equivalent binary. 9 is binary and 23 is binary. If it is negative, how it is stored? Can anyone tell me if you remember? Long back when I took data types, that time I told you.
we take two's complement of it.
Very good, very good. You remember. If it is negative, they are stored in 2's complement form. Right? Very good. You are remembering the rule. It is stored in 2's complement form. Okay? Okay. Now we will see how the bitwise operations are. But first of all, point is clear. These all operators are currently discussed under which data type? Integer data type, whole number. What these operators are going to do? They are going to take the memory representation of the operands. Whatever the operands are, it will take the memory representation of the operands. And what is the memory representation of an integer? It's binary representation. If it is positive, direct binary, right? Like if it is 9, so 1 1 1 0 0 1. If it is 5, then 1 0 1. Okay, so it will take the memory represent. If it is negative, it will take 2's complement of it, right? And then it is going to operate on the individual bits. If it is unary, then single bit. And if it is binary, then the corresponding bits of both the operands. Getting? So whatever the memory pattern is, 0 1 1 0, and whatever the pattern of the other one is. Okay. Now it is going to operate on the corresponding bits. And after operating on corresponding bit, you will get a new binary pattern. Okay. And in that new binary pattern, if the sign bit is 1, then the number is negative. So you have to first convert to 2's complement, its decimal with sign minus. If the sign bit is 0, then direct decimal. No need to convert it to 2's complement. Okay. So all that things I hope you will remember. Now, how they work, I'll just tell you one by one. Okay. But first remember the binary bitwise operators perform bitwise operation between corresponding individual bit values in the operands. Means whatever the operands are on which the operation is going to take, it will take its memory representation, whatever the memory representation is. And I hope you know the memory representation is the binary representation, and then it will work on the individual bits. So if it is unary, only one operand bits. If it is binary, corresponding bits. A's bits and B's bits it will take, and then it will operate on the corresponding bit. Okay. And promotions here also applied, you should know it because you are going to work on integers. So if it is unary, unary promotions applied. If it is binary, binary promotions. Okay. And the ultimate answer will be either int or long. I'm sure float and double won't come because they don't operate only on float and double. They operate only on integers. And you know, when you're operating on integers, the minimum answer is int, then long, then float, and then double. So float double, the question doesn't arise. So the result will be either integer or the result will be float. Sorry, long. Okay. So unary promotion is applied to unary operator and binary promotion is applied to binary operator. Okay. And the result will be either integer or long. I hope the promotion rules you remember, na guys. Char is promoted to int, byte is promoted to short, short to int. So all these are ultimately promoted to int and int to long. Long to float, float to double, but float and double cut off. Why? Because it's going to work only on integers. Okay. Now how they work, that I'll tell you. First remember about tilde operator. So what does tilde operator do? Whatever the memory representation of the operand is, it will just toggle the bits. It will make 0 as 1 and 1 as 0. Whatever the pattern of A is, if the pattern of A is 0, 0, 1, 0, okay, or 1, 0, 0, 1, it is just going to toggle the bit. It is just going to make 0 as 1 and 1 as 0. Getting? That's all, right? There's an easy trick to find out the answer because after doing this, what you'll do, you'll again find its decimal, no? Right or no? So how you'll find the decimal? First you'll check the sign bit. If the sign bit is 1, first you'll take the 2's complement. Then find decimal with minus sign. Okay, so instead of that, there is a very shortcut way. Tilde of A is always, always minus A plus 1. A plus 1 in the bracket. Okay, you can confirm also. Whatever A is, in that add 1 and put minus sign. So if A is already negative, that negative plus 1, whatever you get, again minus. Okay, so remember this, but I'll justify you with the bit pattern as well. With the bit pattern also, I'll try to justify. Okay, and about and, or, and XOR. When the corresponding bits are 1, when both the corresponding bits are 1, the result bit is 1. Otherwise, 0. Getting? Means if one is 0, other is 1, both are 0, 0 only. When both are 1, the result is 1. Otherwise, 0. Or in when at least one bit is 1 from the two bits, if at least one bit is 1, the result is 1. And in XOR, when both the bits are differing, differ means different, different, you understanding, 0, 1 or 1, 0, then only you will get 1. In all other cases, meaning when both the bits are same, you will get 0. Understanding? So that is the truth table. Truth table means bit table, you can call it as. Okay. So tilde operator, what it does, I told you already. Tilde of A, right? It just toggles the bit 1 to 0 and 0 to 1. We'll take some examples, don't worry. Then, in case of ANDing, and what is the very easy shortcut way to find out? Whatever I give, tilde of 5 I give, tilde of 5. So what is 5 plus 1? 6 with minus sign. You'll get minus 6. If I say tilde of minus 5, tilde of minus 5. So first tell me minus 5 plus 1 is minus 4. And already minus sign. It will be 4. Understanding? Tilde of 5 will be how much? Minus of 5 plus 1. That is minus 6. But if you are doing tilde of minus 5, it is minus of minus 5 plus 1. So minus 5 plus 1 is
-4.
minus 4, and minus 4's minus is 4. So in this case, you'll get 4. Here you'll get minus 6.
-6.
Okay, we will justify it. Okay, whenever in technical rounds and all, there you can directly give the answer by the formula. But you can cross verify really why you got that answer by taking an example. I'll show you, I'll prove and show you. Then about ANDing, when both the corresponding bits are 1, then only 1, otherwise 0. ORing, when either of them is 1, means both are 1, at least one is 1, you get 1, otherwise 0. And in case of XOR, when both the bits are different, then 1, otherwise 0. See, if and only if one of the bit is 1, one of the bit is 1 means the other is 0. One is 1, other is 0. 0 or 1. Then only you'll get 1, otherwise 0. Okay? Then the table, the result table, instead of calling truth table, because they are not working on Boolean data type. They are working on bits. Therefore, we just call it as result for bitwise. See, I'm taking combination that A's bit is 1, B's bit is 1, or 1 0, or 0 1, or 0 0. Tilde of A. As it is 1, it is going to become 0, 0, 1, 1. Ending. Both are 1, therefore 1. In all other cases, 0. ORing. When at least one is 1, you get 1. 1, 1, 0. XORing. Both the bits are same, 0. Both bit differed, 1. And both bits same, again 0. Right? Examples will take. Okay? Before that, just unary operator, one example. We will justify it. Why tilde of 5 you got minus 6. Formula wise, I told you it is 5 plus 1 with a minus sign. Minus of a plus 1. That is the rule. So why you got minus 6? That I'll tell you. See here. First, what you'll do, tilde of 5. So you'll take binary of 5. What is binary of 5? For time being, I'm taking 1 byte only. Yeah? Okay. Actually, it is 32-bit promoted. For time being, I'm taking 1 byte. 0, 1, 0, 1. Is this right? Binary 5? I'm sure you have studied this in digital
Yes, sir.
electronics or somewhere. This is 2 raised to 0, 2 raised to 1, 2 raised to 2. 2 raised to 2 is 4, and 2 raised to 0 is 1. So 4 plus 1 is 5. Now you are going to toggle it because you are going to do tilde of it. Okay? So all the bits are toggled. This will become 0, 1, 0, 1, 1, 1, 1, 1. Okay? All the bits are toggled. Done. Now, can we convert this directly to decimal or we have to find out two's complement? Anyone can unmute and tell me so that I'm assured that you know the rule. Can I directly convert to decimal by considering one positions? Like this is 2, then this is 2 raised to 0, 2 raised to 1, 2 raised to 3, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. That is 8. So 2, 8, then 16, then 32, 64, 128. I have to take that and add, or first I have to convert to two's complement. Anyone? Now I hope only Harshraj and Shambali is there. Are others there or no? Huh, answer guys.
Sir, I think as it's a negative value, we have to convert it to two's complement first.
Why it is negative? Because which bit is 1?
Yeah, last bit.
Sign
Sign
bit.
bit is 1. This is sign bit, or you call it as MSB, most significant bit. And this is called as least significant bit. So as the sign bit is 1, the number is negative for sure. And therefore you have to first convert to two's complement. So first convert to two's complement. I told you how to convert to two's complement from LSB till we don't get first one.
First one. We have to
From LSB till we don't get first one, keep it as it is, and then complement. 1, 0, 0, 0, 0, 0. Do you agree?
yes,
Actually,
sir.
two's complement is one's complement plus 1. But I am telling you the direct technique. From LSB till I don't get first one, I'll keep it as it is, and then complement 0 as 1, 1 as 0, 1 as 0, like that. Now, what is the decimal of this? Can anyone tell me? This is 1, this is 2, this is 4,
Two
this is
raised
8. No, so quickly, only the place values you have to add. This is 2, this is
two
4.
raised yeah,
So when you add, it becomes how much?
six.
6
6.
plus 6.
But huh,
As
4 plus 2, 6. But I'm not going to keep it plus 6 only. I have to take it as minus
minus
6 because actually we have not got the decimal of the original answer. This was your original number. This was 5. Correct? This is tilde 5. So actual tilde 5 is this thing. This is the actual value in memory. But to find out its decimal, we didn't do direct decimal. We first converted to two's complement and then decimal. So always remember, whenever you do two's complement and then decimal, you have to give sign minus because you are doing two's complement for negative numbers only. For positive, you don't have to do two's complement. Understanding? And that is the reason you got minus 6. Getting? Suppose I'm telling you to find out tilde of minus 5. Let's see. Now the question is how to represent minus 5 in memory, isn't it? So first represent plus 5 in memory. Let's see. 0, 0, 0, 0, 0, 1, 0, 1. Is this plus 5, guys?
yes.
4 plus 1. This is 4. Remember, this is 1, this is 2, this is 4, this is 8, this is 16, 32, 64, 128. Okay. So here 4 and 1, 5. But we don't want 5. In memory, 5 is not stored, minus 5. So how you'll represent minus 5 in memory, guys? Whatever is the binary of plus 5, it's 2's complement. Whatever is the binary of plus 5, it's 2's complement. So we have to take 2's complement. Tell me 1. From LSB till I don't get first one, I have to keep it as it is. 1,
One,
1,
zero,
0, and
one,
then 1,
one,
here
one.
1, again 1, 1, and 1. This is your minus 5. But actually we want tilde of minus 5, right or no? Tilde of minus 5. So what does tilde of minus 5 does? Just complements the bit, toggles the bit. So this 1 is becoming 0,
Zero,
0,
one,
1,
zero, zero.
0, 0, 0, 0, 0. This is tilde of minus 5. Now, can we take direct decimal of this?
Yes, it's
Because
four.
it is positive, the sign bit is 0. What is the decimal of this?
Four.
4. And we got 4. So actually, there is no need to tally and all because I've already told you the formula. Tilde of A is always minus A plus 1. Okay. No, not invented by me. It is already there from years. So A is minus 5, minus 5 plus 1 is minus 4, and minus 4's minus is plus 4. Okay. So that part is clear. And then ending or example also we'll see. So quickly we'll take this example. Okay, can you study the examples? First, it is V1, character V1 equal to single quote round bracket. So I am storing character, but in reality, it is going to store its Unicode. And what is its Unicode? 41. So what is stored in the memory? On the screen, it will display this graphical symbol, round bracket. But what is the code of that round bracket? 41. So in character, 41 is stored and 13 in byte. Now when you are doing tilde V1, tilde of V1. So by the formula, I hope you are understanding. Just now I gave you the formula 41 plus 1 with a minus sign, minus 42. Do you agree? You can cross verify. Can anyone tell me the binary of 41? Okay, okay, we will do it. Let's see.
1010
Okay, let's see. We will take 7 bit, 6th bit, okay, 5th bit, 4th bit, then 3rd bit, 2nd bit, 1 bit, 0th bit. Okay, so what will be 41? 32?
0.
Now more 9 you need. No? So 8 and year. Do you agree? This is this 0, 0 I'll take here. Here also 0. Okay, and here 0, 0. Is this right, guys?
Yes, sir.
I'll zoom it for you people. Tell me, is this right, first of all? 0th bit 1, that is 1. 3rd bit 1, that is 2 raised to 3, 8. So 8 and 1, 9. And this is 32. 2 raised to 5 is 32. So 32 plus 9 is 41. Is this 41? Actually, it is in character. So character means it is still 15th bit. But 15 bit, what will be there? Zeros only, no? Right? And for before doing the tilt operation, it is promoted till 31. No? Ideally, it is promoted till 31. Character. Just now I told you, no? Before doing operation, the promotions are done. Unary promotion, binary. So char will be promoted to int. So actually it is promoted till 31th bit. But as the 7th bit is 0, so 0 only is pulled till 31. Means if you go till 31 bit also, what will be there? 0, 0, 0, 0 only will be there. Okay, whatever. So this is 41 in binary. Now we have to take its which complement? One's complement. So what will be one's complement? Tell me. Is this going to be 0? Is this going to be 1, 1, 0, 1, 0, and here 1, 1. Do you agree? And ideally above that also 1, 1, 1, 1, 1. Let it be. We are taking the seventh bit only. Ideally, it is still 31 bit, but anyway, above everything is 0, 0, 0 only. Therefore, it is okay till here. Now tell me, this is positive 41. Then you took tilde of 41. Is this right? This is tilde of 41. Now we want to find out its decimal. So can we take direct decimal or I have to convert it to 2's complement? Tell me, guys. Huh? Can anyone tell me? Am I supposed to convert it to 2's complement again? Why
Oh,
pause? Huh?
yes, sir.
Yes, sir.
Why? Because the seventh
Last
bit
bit
is
is
1. Is 1. So means the number is negative. So you have to convert it, right? So this will be 0, 0, 1, 0, 1, then 0. This is going to remain 1 only and 0. I told you, from LSB till we don't get first one, keep it as it is and then complement. Now, what is the decimal of this? 32, 840 and 242. But am I supposed to take 42 or minus 42? This is your actual answer, tilde of 41. This is the real answer. But
minus
we cannot take direct decimal of this. Therefore, first I
Minus
have to convert this to, first I have to convert this to 2's complement.
42.
After converting to 2's complement, I got 42. But I have to put minus sign because you didn't get direct decimal of your answer. This was your real answer. And this decimal is not the decimal of the direct answer. It is the decimal of its 2's complement. So whenever you get decimal of a 2's complement, that answer has to be negative. Getting? It is minus 42. Agreed? You can cross verify also in J shell. Okay. If we go to J shell, okay, I'm just writing tilde of 41. Tilde operator 41. Is it printing minus 42? Yes. Okay. And same thing is if you do it for tilde of minus 41. Tilde of minus 41 will be,
41.
you didn't
Yes,
understood that.
sorry, minus 42 అట్లా ఉంది.
Tilde of minus 41.
40.
40. Positive 40. Getting? Okay. So now talking about the other operations. That is V1 and V2. V1 or V2. V1 XOR V2. In that case, can you tell me V1 is 41? Actually, it is a closed bracket, but that closed bracket is in which form? Character form. So it is ultimately Unicode binary only. Okay? And V2 is 13. So 41 and 13's ANDing. Okay, so 41 in binary. Just now we have found out. See, this is binary of, quickly, can anyone tell me? This is binary of 41. Tell me binary of 13. Can I take
1,
1, then 4? 8 and 4, 12. And
0,
here
1.
1. Okay? And here what will be there? 0. Okay? And above this, 0, 0, 0. Okay? And remember, this byte is also promoted to integer, and who is also promoted to integer? Char. Actually, char is still 15th bit, but that 0 is also promoted till 31, and byte is still 7th bit, but that 0 is also promoted. So assume here it is promoted. Now quickly can you tell me the ANDing operation? If you do ANDing of this, chalo, fatafat. 0 and 0, 0,
0,
0 and 0, 0, 1 and 0, 0,
0,
0 and 0, 0, 1 and 1,
1,
1, 0 and 1, 0, 0 and 0, and 1 and 1, 1. How much is the decimal? Can anyone tell me?
12,
9.
9,
9. हाँ, ठीक है इसलिए it is said in our Puranas also. That is the reason you always have to read Bhagavad Gita, right? Speak wisely. When- Whenever you speak, in your mind, you have to think first and then speak, right? Then coming to the next one. But when you think, you should not take so much time to think that someone is overtaking and going ahead. In real life, also, when you take decisions, you should not be too fast, but you should not be too slow also, such that someone else takes that opportunity and go. Understanding, guys? But be wise in taking any decisions. Okay. Now, who will tell me about ORing? ORing. First two ORing. So 0 or 0,
0,
0. 0 or
0.
0, 0. 1 or 0, 1.
1.
0 or 0, 0.
0.
1 or 1,
1.
1.
1,
0 or 1,
0.
0 or 1, 0.
1,
Then 0 or 0, 0.
0.
And 1 or 1.
1.
1,
What will be the decimal? Let's see. This is 32. This is 8. This is 4. And this is 1.
45,
Chalo, fast. 32,
44, 45,
40.
5,
Okay. Chalo, 45. As you are saying, I'll write it. I'm coming to XOR. Tell me. 0 XOR 0, 0. 0 XOR 0, 0. 1 XOR 0. Can anyone tell me? I'm considering the first two lines, guys. So 0 XOR 0, 0. 0 XOR 0, 0. 1 XOR 0. XOR
1, 1,
1. Clear? 0 XOR 0, 0. Third, next, 1 XOR 1,
0,
0.
0.
0 XOR 1,
1,
1.
1. 0 XOR 0, and 1 XOR 1, 0. When both the bits are same, the answer is 0. When they differ, it is 1. Now, how much is this? This is 32, and this
40,
is 4. Uh-huh.
36, 36,
36. Right? You're absolutely right. 36. Isn't it? We will cross verify. Okay, see here. The answer is 9, 45, 36. You can tally also over here. Like what I'll do is I'll take that bracket only and direct I'll AND it with 30. Is it coming 9? Then bracket or 13. Is it coming 45? Bracket XOR 13. Is it coming 36? I hope you got it. I haven't taken examples of negative numbers. It could be negative also, but if it is negative, I hope you should know it. You are not supposed to take its binary directly. You have to convert first to 2's complement and then do it. Okay. So hope that part is clear. Now These operators, which we have just now discussed, and or an XOR, three, they can be used as compound assignment also. Means they're doing bitwise ANDing as well as assignment, bitwise ORing as well as assignment. Understanding? Like if I want to do A is equal to A and B, means my intention is A's bit representation, B's bit representation, and it, and whatever answer come, again I want to store in A. Then instead of doing it like this, you can do it in a shorthand form like this. A and equal B. Understanding? A and equal B. So this is dual operation. It is doing bitwise ANDing as well as assignment. A and B are ANDed also, and the result is stored in A. There is only one speciality about this compound bitwise, that it does implicit casting. Means what it does is A is equal to T, where T is the data type of A, and A and B. Getting? So A and B are ANDed. So for ANDing, it will do the appropriate promotion. Means it will be promoted to either int or long, B int or long, and then the answer whatever come. But whatever answer come, it will on its own cast it to T, where T is the data type of A. This is not happening when you write in a expanded form. See, A equal to A and B. And suppose A is byte, okay, and B is byte. Do you think error will come if I write A equal to A and B, where A and B are byte? In the first case, not using compound, the
Yes, sir.
normal one. Yes. Why? Because in that case, the answer is going to come as integer. I told you now, before doing ANDing, byte is promoted. Byte is promoted. Now, some may say both are byte only. Why? But the rule is there. In Java, the minimum answer is integer. So, byte is promoted to integer, byte is promoted to integer. Therefore, the answer is integer. But can you store an integer in a byte? It is a narrowing
No.
situation. And Java doesn't do automatic narrowing. Therefore, here it will give an error, incompatible type, found integer, required byte. It will say possible lossy conversion from byte, sorry, from integer to byte. But that error won't come if you do it with compound. Understanding? Why? Because in that case, implicit narrowing takes place. It will do A and B ANDing. Okay, but for doing ANDing, it has to promote it. A will be promoted, B will be promoted. Then the answer will come as int or long, and then it will on its own narrow it to A's data type, whatever the data type of A is. Only the problem in this case is there may be loss. So you have to wisely select it. Okay. So implicit narrowing is the speciality of this compound assignment. Implicit narrowing happens. One point you have to remember. And second, as it goes with equal, as it is going with equal, guys, its precedence is lower. Why? Because it has gone with equal operator. Equal operator is having a lowest precedence. You understanding or no? Okay. So remember, A and equal B or C if someone has written. In that case, ANDing is not done first. ORing is done, guys. It will do ORing first, whereas standard precedence is ANDing first and then ORing. But in this case, what happens? First, the ORing is done. Understanding? It will do ORing first and then it will do ANDing. Why? Because that and has gone with equal. Equal precedence is lowest. Getting? It is said also na, that whether to go with Pandavas or whether to go with Kauravas. राइट. तो आप कौरव के साथ गए या पांडव के साथ गए तो आगे का सब कुछ अलग हो गया. राइट. तो किसके साथ जाना है रियल लाइफ में वो भी बहुत वाइजली तय करना है. विथ whom you go that also decides. So देखो प्रोग्रामिंग में भी ये एंड इसके साथ चला गया, therefore उसका प्रेसिडेंस कम हो गया. when you use it alone normal its precedence is more. Okay, so speciality याद रहेगा. I hope you will remember the speciality of it, that it does implicit narrowing. Okay, and as it is compound but assignment, it will follow the assignment precedence only, and assignment's precedence is lowest. Okay, so quickly I'll tell you about that too. See, B and equal A. So it will do ANDing of B and A, and the result is stored in B. But when it is storing the result, before that only it is casting it to B's data type. See, and B and A. So for doing ANDing, it will do the promotions. Whatever answer you get, it will cast to T, where T is the data type of B. Understanding? Clear? See, I'll give you a simple example. Byte A equal to 41, suppose, and B equal to 13. Right? And if I'm doing A equal to A and B, and just now we have found out the result of 41 and 13. Remember, no? 41 and 13 is 9. So ideally the answer should be 9 in A, right? But it will give an error. Is it giving an error? Incompatible type. Because A and B, the answer has come integer and you're trying to store it in byte. Understanding? But if I do it like this, A and equal B, will it do implicit casting? So after doing implicit casting, the answer is 9. You can check. Is 9 stored in A? No error has come. When no error means this proves that implicit what has happened, casting. Okay? Okay? And same is the case for ORing and same is the case for XORing. Remember, and XOR or. If you use normal, their precedents are like that. And is having more, then or, and then, sorry, XOR and then or. As an example, we will take, see, integer V0 is equal to minus 42. When it is minus 42 means it is in 2's complement stored, remember. Okay. And V1 is close round bracket and V2 is 13. Okay. So what is V0 and equal 15? So first of all, you should represent minus 42 in which form? Minus 42 in binary form, and then add it with 15. Okay. So can anyone tell me plus 42? I'll take till here only.
Yes, sir.
Plus 42. 32 and 8, and here 1 I have to take, and this 0.
0.
Do you agree? This is plus 4, but we don't want plus 42. We want minus 42. So how you will represent minus 42 in memory? 2's
Two
complement.
2's
Okay,
complement.
so what is 2's complement? This is 0,
zero, one,
then this is 1,
one,
okay, and here 1, 0, 1,
one,
0, all 1, 1, 1, 1. Getting? 1, 1, 0, 1, 0, 1, and that is going to remain as it is. Okay? And as it is the integer, it will have 1, 1, 1, 1 above also because it is actually promoted till 31. So 31 bit is also going to have 1 only because after this everything is 0. So in 2's complement, everything will become 1. Okay, that is minus 42. So this is minus 42 in memory. Yeah? This is plus 42. And minus 42 is plus 42's 2's complement. Now you have to add it with 15, right? They are saying it, and it with 15 and store it in integer. So what is 15 in binary? 8 and 4, 12, 12 and 2, 14, and 1, 15. So are all four zeros, sorry, four ones, 15,
Yes, sir.
right? And above this, everything is 0, 0, 0, 0. Everything till last is 0. This is 15, guys. Now I am telling and them 15. Okay. So when you add, can you tell me, are they all going to be 0, 0, 0, zeros? Everything is 0. Here also 0. Here you'll get 1. Here you'll get 1. Here also 0. Right? Everywhere at least 1 is 0. That was 0, 0, 0, 0, 0. Here 1, 1, again 0. So how much is this decimal?
6.
This is 4 and 2, that is 6. Because here, obviously, you're going to get zeros. So all above this are zeros. So no need to take 2's complement, direct decimal. So 4 plus 2 is 6. Getting? So you got that way here 6. And same thing when we do V1 or V2. So V1 or V2, just now we have done. Close round bracket is 41 and 13. We did it in the previous slide. Yes or no? 41's binary and 13's binary. And when I did OR, we got 45. Okay. But whatever ORing you did, the result is again stored in V1 only. Getting? It is stored in V1 only. Okay? Then we will move with the next operator, guys. Next, quickly, we will
Yes, sir.
discuss about this shift operators. Only we'll discuss about this. Maybe examples in the next session we'll see what this shift operators do. Okay. Now, all the three shift operators, they all are binary. You have to apply it on two operands. Okay. So this is left shift. This is right shift, but sign fill right shift. And 3 greater than is called as zero fill right shift. I'll tell you the difference between them. Both are right shift, but this is sign fill right shift and this is zero fill right shift. Okay, these are three binary operators, and A is always A and B are both always integers. Always it is supposed to be integer, meaning you're understanding, na? Char, byte, short, int, long. You cannot have float and double and boolean. Point one. It will consider the memory representation of A. It will consider memory representation of A. And what is memory representation of A? It's binary equivalent, 0, 1 pattern. If it is positive, it's binary. Negative, that binary is 2's complement. Okay. So what these operators do, they take the binary representation of the first operand and shift the bits of the first operand, that is A, either left side or right side n times. Getting? Whatever the bit pattern is. 1, 0, 1, 1, 0, 0, 0, 1. This is the bit pattern of A. And then you are telling shift right side or left side n time. So these bits are getting shifted either left side or they are getting shifted right side. Okay. Now, what is the difference between these two? We will see. In the first case, just remember it is going to shift left side. So suppose we are shifting left side. So 1 goes out. Here what will come? 0. Here 1. Here 1. Here 0. Again 0. Again 0. Then 1. Now the question is what will come in LSB? All these are shifted. The MSB is gone out. The second last bit has come in the last bit. So what will come in the LSB? Always 0. Doesn't matter what was previously there. Always what will come inside? 0. Okay, in case of left shift, remember, in case of left shift, after doing shifting, what comes in LSB? Always 0 will come. Okay, about right shift, I'm telling. If you are doing it right shifting, okay, so 1 will go out. Here, what will come? 0, then here 0, again here 0. Here 1 is going to come. Here 1, here 0, here 1. But the question is, what will be there in the new MSB? Okay. So remember, guys, if it is 2 greater, it will be sign fill right shift. Means whatever is the old sign bit is dropped there. If the old sign bit is 1, 1 is preserved. Old sign bit is 0, 0 is preserved. Understanding? So 1 will go out. This 0th bit goes out. 1 bit go to 0th bit. 2th bit at 1 bit. So 0, 0, 0. This 1 has come here. This 1 has come. This 0, this 1. What is coming in MSB? So if you are doing 2 greater right shift, always the old sign bit. So if your old sign bit is 1, 1 is dropped. And 1 is preserved. Old sign bit is 0, 0 is preserved. So therefore it is called as sign fill right shift. Therefore we call it as sign fill right shift. Okay. But when you use 3 greater than, when you are using 3 greater than, in that case, irrespective what the sign bit is, always 0 will come in MSB. What will come in MSB? Always 0. Meaning the old sign bit is 1 or 0, doesn't matter. What will come in MSB? 0. So therefore, this is called as zero fill right shift. This is called as sign fill right shift. Getting? And always remember, whenever you do shifting left side, 0 is coming inside, therefore value is doubled. So when, but integer doubling, not float doubling, integer. So whatever the old value is, it is doubled. And when you do right shifting, the value is half. It becomes half. Half but means like 9. So nine's half will be 4 only here, not 4.5. It is called as floor half, not float half. Floor half. Okay. So right shift always half the value and left shift always doubles the value. But is the difference between 2 greater and 3 greater clear? 2 greater, what will come in MSB?
Sign bit will be dropped.
Old sign bit. Whatever the old sign bit, it will drop. Old sign bit 1, 1 preserve. Old sign bit 0, 0 preserve. What about 3 greater?
Always 0.
Always 0.
Zero.
Clear to you. Okay. Only one point about this I have to tell you about this N, which is called as a shift distance. N is called as a shift distance. But internally, what it does is, okay, and here also remember these 3 operators are going to operate on only integers. And when they are operated on integers, here also your answer is either going to be integer or long. Okay. Now, what that shift distance is, ideally how it is calculated.